right. Hello, everybody, and welcome to the stream. We are doing the second stream of the week. We're continuing on Editor Gizmos, which is where we left off last time. So, while I wait for folks to file in, I will go ahead and just mention a very special thank you to the folks here on the screen. They are the supporters of the channel, starting with our partners, which is the highest tier of support on Patreon, as well as YouTube memberships, and they are Arslia, Garbolas Inc., Patrick Coolman, and Wen Chang. I'd also like to thank all the other supporters listed on the screen here. They are the other tiers on Patreon and YouTube, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. And I also appreciate each and every one of you who come here on the stream and interact with me and ask questions, follow along with the project, and even those of you who are viewing this on YouTube as an archive later on. Thank you all very much for being here and following along with the project. None of this would be possible without you guys, obviously, so thank you very much for that. All right, so tonight we are going to continue our work with gizmos. So just to give a quick recap as to where we were last time with that, let me pull up our debugger here and I will launch so we can have a quick look at that. So last time we implemented the hover logic so that we can look at a gizmo and hover over the various axes and have those highlight to give us a little bit of feedback as to what we're interacting with. That works with the individual axes as well as the combination, the two combination axes as well as the entire thing, right? And so tonight we're going to do our best to get all of those things implemented so that we can kind of drag them around and use them accordingly so that we can actually move the gizmo around, right? We did get it working on one axis last night, so the x-axis, we were able to drag that along, right? And so tonight we're going to get the others working, get these combination ones working, and then maybe even move on to some of the other modes, because we have some other modes to implement as well. So this is the move mode, we also have the rotate mode to do, and then we also have the scale mode. And what we might even do, I don't think we'll get through all of that tonight, but what we might do is take a small detour and just hook up some basic code for object selection so that we can actually use our gizmo to sort of move something around, right? So we'll see kind of where the night takes us. I do want to point out that this is an interactive stream, so if you guys have any questions or comments, feel free to jump into chat, and I keep an eye on it, so I will do... I'll answer questions and keep up with that to the best of my ability. So, with that said, I do also want to take a quick second and point out that I have gone ahead and done a few small things on the repo. So I've gone ahead and there were some pull requests and some issues that resolved some issues. So I've gone ahead and merged some of those. So I'll really quickly just kind of go through those because I think they should be here at the top. Oh, are they arranged in order? I'm not sure how they're arranged actually. Yeah, okay. They are at the top. So this one here is basically just to use std error instead of std out to print errors in Linux. And then I also added a multiply add for vector types. This was something that was kind of missing out of our vector types, and I wanted to add it because there's a few places where we've already kind of done this, and we didn't have it. We were also missing some multiply scalar on some of the vector types, so I went ahead and added those too. All the multiply add is it takes 3 vectors, and it multiplies the first 2 and then adds the result of that to the third, right? So we've implemented that for vector 2, vector 3, and vector 4, and then added the multiply scalar in for vector 4 and vector 2, right? I didn't feel it was worth doing it on stream here, so I went ahead and did it that way. So if you guys do notice something and you want to put in a PR, I do look at them on occasion. I've not been real great about it recently, just because I've had a lot going on, but I am going to try and do a much better job of keeping up with those in the future. So all the ones that are there right now, I'll have feedback on them, right? Okay, so with all that out of the way, let's jump into this. So what we want to do is we want to kind of enhance our what we have here in terms of all of this logic here that we're using for interaction, and sort of make it a little bit more reusable, if you will. And so I think probably the part that I'm going to start on is probably the interaction for the editor gizmo, and then we can kind of come back to some of this stuff. So editor gizmo C, and we're going to go to begin. So right now, what we kind of did last night is we kind of just hacked some of this stuff in place just to kind of get a single axis working, which is all well and good. But there's going to be a lot of repeated code if we do all this for every each and every axis, right? That's not going to be very sustainable, right? So what I'm going to do is I'm going to take this origin and I'm going to move it up here to a higher scope. The interaction plane needs to stay, well, technically speaking, that actually can move out of here as well. That can technically move down here, and we'll go into the reasons why in a few minutes. We want that outside the switch statement, all right? The raycast itself, technically speaking, could probably be moved out as well, I'm thinking. Let's see, we have interaction plane. Yeah, so we can probably take, actually, wow, I really spelt initial wrong there, didn't I? Okay. So I'm thinking we can probably, like, all of this logic is going to be the same. This raycast logic is actually going to be the same, with the exception of the interaction plane that we generate. So actually all of this can go down here. Right? So the only thing that we really need to determine is basically our interaction plane's direction, right? And so I think what we'll do is we will go to the top here, and let's see, we have the origin there, so we'll go ahead and say vec3 plane direction, right? And then one other thing that we did, which was also kind of a hack, was we said we're just going to use the z-axis here and hard code that, right? But we don't actually want to do that because the gizmo itself can be rotated in space, and if we just use the z-axis like directly, that's not really going to give us what we want. So we actually need to calculate what the z-axis should be based on the current transform of the gizmo. So what we actually need to do here is we actually need a mat for, and we're going to call this gizmo world. And we're going to get the transform world get. I'm going to send the address of gizmo, gizmo xform, right? And then in here, I'm just going to actually take this out and move this guy up a line. What we're going to do in here is all we have to do is set plane direction. And in this case, we're going to set it to mat for backward, which is going to give us along that z-axis, right? And here we can just pass gizmo world. Okay. And so we have y-axis here, and we have z-axis here, okay? So all we're going to do is basically the same idea for the other axes. So we'll say, whoops. Let's go with plane direction equals, and then in this case, since we're going to be working with the y-axis, I think we're going to want to do mat. Let me think about this for a second. Yeah, mat for down. Okay, Gizmo world. We may be wrong about that. We may have to adjust some of these. We're just going to try some values that initially make sense. It might wind up having to be up. We'll see. And then plane direction equals mat 4. And in this case, we're going to say left. Gizmo world. Okay. Then at that point, we can go ahead and just delete this and instead say plane direction, okay? And that is going to give us essentially the normal of the plane, right? So the normal is not necessarily going to be the same direction as the axis we're going to work on. It's actually not going to be that, right? So on the x-axis, we want the z-axis. On the y-axis, actually, wait a minute. I may have those backwards. So in the z-axis, we're going to want the x-axis, which is left. That makes sense. On the y-axis, we are going to want... Yeah, we are going to want it all on that. Okay, I think that's right. We'll find out. So the other thing to keep in mind is, in fact, let me build this again so I can run it and explain this visually. Where is it? There it is. Okay. So the other thing is, if we take a look at this Gizmo, we note that the plane of interaction for the x is on the z-axis, right? But the plane of interaction for this x-y combo is actually going to be on that same plane. If we look at the z-axis, the interaction is going to be basically on this direction facing here, and this box is going to be the same, which means for the y, this box down here is going to be the same. So we can actually group these together and use the same plane, interaction plane, for those axes as well. So I hope that makes sense. So all we have to do really, at least for here to support that, is we'll say case 3, which is the xy axis, right? That's that axis combo. And then we want case 4, which is going to be the xz axis. And then down here, we're going to say case 5. And in this case, we're going to want the yz axis. Right? And so right there, that knocks out 6 of our axes. Now, obviously, if we have 6, which is our XYZ, that one for right now we're going to leave in to do, right? So we'll say to do plane facing camera. And that won't be too bad, but we're just going to do it last, okay? So in this case, we're going to say return. Right? So we'll tackle that one last. So that'll give us our interaction planes for most of our axes that we're going to be dealing with. So that should do it for that. The other thing that we need to think about is within the handle interaction, So right now we have a mouse drag interaction within the move mode, and we're just saying we're going to do all of this under the axis index of 0, which again, there's a lot of this stuff that we're going to wind up being able to reuse. So we actually need the Gizmo world, so I'm actually just going to do this. We actually need that regardless of axis, so we're going to grab that. And let's see, we're going to need two things to generate here. So we also did a little bit of sort of hard coding hacking here, where we just hard coded it to sort of move along the x-axis. Again, if the gizmo is rotated in space, that's not going to work, right? So we actually need to calculate what the proper direction is for that. And again, we'll do that similar to how we did above, although this section is going to be a little bit different. So we're going to need two things here. We're going to need vector 3 for direction, and we're also going to need a vector 3 for translation, right? And we're going to use direction to calculate translation, and then we're going to pass translation directly to this, right? So the thing that this also means is these two lines here could move outside of this case, right? And then I believe, let me see, I think we can actually move, should we? I think we can actually move this as well, because the only thing that's really changing here is the interaction plane. Yes, as well as diff, I believe we can actually change as well. So let's go ahead and move diff. Whoops. Right, let's move diff. We'll put diff here. And then obviously diff requires interaction, so we're going to move these guys up here. Right? And then we technically don't have anything in X right now, right? Instead of a bunch of if-else's, I'm going to change this to a switch. And I'm going to delete this. And then case 0, which is our X. And what we're going to do here is within X, we are going to generate our direction and translation. So the direction is pretty straightforward. Direction is equal to mat for, in this case, we actually want left. And we're going to pass the gizmo world. And then for the translation, we're actually going to perform a projection. So we're going to take the diff, and we're going to project that diff onto our direction vector. And what that'll do is it'll give us a sort of magnitude of movement for us to be able to move around. So the way that we do that is we say vec3 dot, and the first vector is going to be diff, and the second vector that it's going to be projected on is going to be direction, right? And then to actually perform the projection, the second part of that is we're going to say vec3 mul scalar, right? And the first value of that is going to be direction, since that's what we're projecting onto. And then we're going to take that dot product that we generated, and we're going to use that to perform that projection. So I'll just leave a note here that we are going to project, project, geez, let me try that again. Project diff onto direction, right? And it'll basically take that diff of input that we have from the raycasts, and it'll just project it onto that direction. And it'll essentially work the same way as it did before, right? It's just now it'll support it any way that we rotate it, it'll actually support that. Okay. I'm going to say default return here. Right, that way any of these that aren't supported yet, we can just, you know, not run into errors and stuff, right? So let's go ahead real quick, and I want to actually build this. Whoops, let's see. Translation set but not used. Oh, yeah, that's probably true. We forgot to plug that in down here. So let's get rid of all of this. And we'll say translation, right? Build. And we will there it is. Okay, we'll run. And let's just make sure that we didn't break anything. Okay, so that still works, right? We don't have anything hooked up for these other axes. In fact, we're using the wrong kind of raycast for that. So we do have some issues on the other axes that we have to figure out. For now, let's go ahead and put in the other axes here. So we're going to say case 1. This is going to be on the y-axis. So our direction is going to be up, I believe is what we're going to want. So mat for up, and that's going to be Gizmo world. And then translation is actually just going to be a copy of this. Right? Now, you might be wondering why we're not doing this translation bit down here. That's because the other axis, the combo axes, are going to work a little bit differently, I think. So if we do case 2, and this is going to be the Z axis, we're going to set direction equal to mat for backward, I think is what we use. Might be forward, I'm not sure. I'm going to try backward first. And then, again, this is pasted. Okay? Now, the case of 3, which is the XY, that is basically going to say translation. I think we can just use diff directly. Because there shouldn't be any difference on the third axis. It should only be on the 2 axes that we're sort of moving around on that plane. So I think we should be good to use diff directly. We'll try it and see how it works out. So let's go ahead and write and build. And we'll run. Right, so this should still work. Let's see if this combo works. It doesn't look like it does for some reason. Did we not hook up? Did we not hook something up? So 3 is the XY combination, I believe. Yep, it is. So these both have a plane direction. What are we missing here? Transform, translate the translation. Copying over the intersection. Oh. It might help if we put break statements where they kind of belong. Noob mistake. Break. Yeah, it was basically falling through to return, I think is what was happening there. Try that again. Okay, so this axis still works, and now we can move along the combination axis, right? We're just moving along that same imaginary plane as before. And actually to prove that, I'll go ahead and load up a scene, and I'll just sort of come in here so that we can see that it's moving correctly along those axes, right? So I think that should be good to go. All right, I think there is something that we're gonna have to figure out based on distance away from the gizmo. I think we're probably gonna have to do some scaling on the diff with that, because I've noticed now that we're really close to it, it's not very sensitive, but if we move way far back, it's much more sensitive. So we may have to use that same scale that we're using for the distance here on that, but we can try that later, right? It works enough for now for us to be able to test some stuff. All right, so I think the next thing, actually, come to think of it, all of these axes can do the same thing. So case 4, which is, what was that? XZ and then YZ. So XZ and case 5. Those are all going to act exactly the same way as well. Because the diff will essentially act the same way against those planes. So in that regard, there's not a whole heck of a lot that we have to do. And I'm thinking actually case 6 is probably going to wind up being the same thing. But we'll test that out when we get there. I did notice that we were getting some errors on one of these axes. I think it might have been this one. So I may have to do something different here. In fact, let me test the other axes real quick. We've got ads coming up here in just a second, so. All right, so on the Y doesn't do anything yet, and Z, oh, Z works. Yep, so our Z axis works. Does our combo work? Our combo works, yes, okay. Y doesn't work for some reason. Does the combo work? The combo works, but Y axis doesn't work. Okay. All right, we are gonna break for ads real quick. Ads usually take about 1.5 to 2 minutes. So for those of you who don't have ads and can still hear me, how are you guys doing tonight? Well, I hope. Trying to get into the habit of pausing the stream whenever we have ads so that way you guys don't miss anything. Got a little over 30 seconds left on ads. right, and we are done. Z Hayes, thank you so much for the follow. I appreciate that. So, I just did a little thinking, and I think I know why our y-axis isn't working. And this kind of gives a hint to that. So, we were able to use the same planes of interaction for Z and YZ and X and XZ, or XY, right? And that all worked fine, sort of as expected. And this appears to be working as well. I can load a scene here to verify that. Let's move this outside of here, right? So, I mean, this at least appears to be working correctly. My raycasts are actually still firing as well. Right, so if I move this around over here, I think it just kind of, consistently stays where I've left it. So I think what is happening is we actually need a different plane of interaction for the y-axis. And I'm actually wondering if this is, the more I think about it, the y-axis plane of interaction should probably also face the camera. However, instead of using diff like we do for the other combos, we would project it here in a similar fashion. So I think this is correct, but I think we need to base our direction off the camera, not necessarily the world in this case. And that just leads me to think that, that way our plane of interaction is basically right in front of us, and we can move up and down on that plane of interaction. And technically left and right, but that won't do anything unless we are on the 3 combo. So, I guess the first thing we'll have to do is fix the plane of interaction. So instead of down, which is what we need for the combo, but not what we need for this. So in this case, we actually need 2 different things. So our plane direction, we're going to have to base on our camera. Do we have, let's see, I guess we'll say camera backward. And then we need, let's see, do we have the state? We don't have we don't have the camera here at all, do we? That is an issue. Because we're passing the ray information, but we're not passing a camera to be used. Which technically we are going to need that for this as well as the 3-axis interaction. So we're going to have to make a small change to our interaction begin. We're going to take the gizmo, we're going to take the camera, pointer to the camera. In fact, that can be, yeah, that's fine. And then we'll just pass C here. And we'll set our plane direction to that. So we put that after the gizmo, so let's go gizmo H. Gizmo H. If you guys have any questions, by the way, feel free to jump into the chat, or if you just want to chat and say hello, that's fine too. Okay, so we did, this was handle interaction. Was this begin? Yeah, this is interaction begin, which actually handle is going to need it too now that I think about it. So we're going to need to forward declare this actually. So struct camera, and then we're going to add struct camera pointer C, and we're going to do the same thing here, struct camera pointer C. And then we'll go back to the implementation file. We will add that here. So we'll say struct camera C. Go to the top here. And include, was that under world? No, what was that under? What was that under? I want to say that was under, I don't think it was resources. Renderer maybe? Yeah, renderer camera, okay. So we have camera there, and now we can go ahead and get what we need. So in this case, it's going to be interaction begin is what we're going to handle first. Camera backward, I think is what we're going to use for that. And then for the handle interaction, Gizmo mode move. I think, yeah, the direction on this one is going to have to be, well, we do want the direction to be mat4 up. But what are we going to scale that by? So diff is taking, actually diff might still give us what we need. This section of code might be okay. All right, so let's write all, what did I miss? Oh yeah, testbed main. All those calls are going to be, everywhere we call it basically is going to be wrong now. So this is going to be state. Badre, thank you so much for the follow. I appreciate that. Thank you. So this is going to take world camera, state world camera. Oh, that's already a pointer. That's right. Okay, so I don't need the address of it. So it's just going to be state world camera. And this one is also going to need that in mouse move. So we'll say state world camera. We should be able to compile now. All right, so let's swap back to our debugger and have another crack at this. So now we will try to move up, and there we go. That is, in fact, what we needed. So we can move up and down, we can move left and right, and forward and backward in the scene, and I believe all of our individual axes are going to move as well, or our combinations rather. This one, oh okay, that's doing some weird interesting things. It's actually scaling for some reason. Okay, so it looks like there's a bit of a bug there. And the center one doesn't do anything yet. So the center one's also going to work on the plane that faces us. So let's go ahead and tackle that really quickly. So that is going to wind up being in, I think this is actually going to work the same way. In fact, I'm going to hedge my bet on it and say case 6 here. X, Y, Z. I think that's going to work exactly how we expect it to work with diff. I think we can literally just copy this line, yoink, and paste it here, and get the same thing. So now we should be able to move on all 3 axes. So we'll switch modes here. And when the whole thing lights up, we should be able to... disappeared on us. That's interesting. So, why has it done that? Interesting. I wonder if we got a nan somewhere. Or not a number. So just thinking it through, the interaction plane should be facing camera, which is what we have there. It is positioned at the origin. The normal faces the camera. I get the feeling that's right because it works for the y-axis, but I'm wondering if we just can't go with diff on this. I wonder why. I wonder why that's not working the way I think it should be working. Because it's the same type of interaction that we have here. The only thing that's different between these 3 and this one is where the plane is oriented. I wonder if maybe it needs the forward vector. I can't imagine that being the case, but... Okay, I'm gonna have to put some debugging here. So... I think what we'll do... I'm gonna undo that because that didn't fix the issue. I think the issue is here. So we'll do a K trace. CM Griffing, rating with a party of 65. Awesome, thank you so much. I really appreciate that. Welcome, welcome. How are you doing tonight? So, just to give a quick intro here, my name is Travis. I've been working on this project called the Kohi game engine for about 2 years now. I just started streaming on Twitch this year. It started off as a YouTube project. Basically, we're building an entire game engine from scratch in C, using as few libraries as possible. Right now, we're only actually using 1 to load images and 1 to load fonts, and that's it. We're implementing everything else from scratch. Right now we're on Linux, using NeoVim as our editor, VS Code as our debugger. We support Mac, Windows, and Linux for right now. So yeah, that's kind of where we're at. First time chat from TF Jonestown. Howdy, hello. Mariano555, hello, welcome. Thanks for the raid for the follow the other day. Yeah, of course. I always follow channels that I find interesting, right? So let me do a shout out for... I'm still learning how all this stuff works, so I think I did that right. There we go. Please go follow CM Griffing if you were here before the raid. Definitely do that. So, all right. So to catch you guys up on what we're working on right now, in fact, I think I can build this right now. So what we are doing at the moment is we're actually implementing a editor Gizmo. And so basically what we've got, I'll blow this up so you guys can actually see it maybe a little bit better, is we have this gizmo in the middle of the world right here, and we can load a scene. I'll do that in a second, with different modes, right? And so right now it's just represented as lines. So we have this sort of none mode that just acts like if you select an object, it'll tell you where it is. We have a move mode, we have a rotate mode, and we have a scale mode. And we are working right now on the move mode. And we've got raycast hit detection working so that we can hover over the individual axes, or the combination axes between two of them or all of them, right? And we're implementing the logic right now to be able to move this around in space. And we've got a lot of it working correctly. Some of these combination axes are a little bit janky. And right now I'm trying to troubleshoot why when I do this all axes, it just kind of goes away in some cases. Now it's not doing it, so I'm not sure what was going on there. But that's kind of what we're working on tonight. First time chat. No Yane Rain. You're doing great. Project sounds awesome. Cool. Yeah, I hope you guys like it. So the entire purpose of this project is it's supposed to be educational, right? So the idea is I'm looking to create a resource for those of you who are interested in game engine tech, and are looking into how you might go about building one. So this is just my way of building it, and we're doing this with using C instead of C++. We are avoiding things like object-oriented programming in favor of more procedural logic and things like that. We've built our things like our own allocator, our own messaging systems. We're using Vulkan as a backend. And so the idea behind this is I was hoping to provide like an educational resource that I kind of wish that I had when I was learning how to do all this stuff. And so that is kind of the goal here. So, all right. So I hope all that makes sense. The other thing that I did want to show is, we do have text rendering here. I can load up a scene. OBS kind of kills my frame rate a little bit at the moment, but basically what we're looking at is we've implemented a few different things here. Let me make this maybe not full screen. So we've implemented a few things here. We have a basic terrain implementation that's not been optimized yet, but it's a height map terrain with material blending. We have Phong lighting for the time being. We are going to be implementing PBR. So we have some basic dynamic lights here working that are animated and so forth. I could do raycasts into the scene and pick objects like that. So hits show up as yellow, non-hits show up as magenta. I've got oriented bounding boxes working, things like that. So you actually do things. Good change from CM Griffing. Ooh, burn. Yeah, I'm trying to do things. There are points in any project like this, especially one of this scale, where it's like you don't really have a lot of visual updates for a while, and then all of a sudden there's just tons of visual updates, and that's kind of one of the things we're in now. We worked on this terrain, and it kind of took us a while to get through that, but thank you guys for the follows, by the way. I appreciate that. But, once we got kind of past that hurdle, then we were able to put the grid in and able to put the ray casting in and the hit detection and things like that. So we're at one of those points now where thankfully we have a lot of visual updates that are happening kind of all at once. But yeah, if you guys like this, I also have, I'm trying to be a little bit organized with the project. So I actually have a website dedicated to this project. So it's kohiengine.com. I'll slam that into the chat as well. And this basically kind of gives you a little bit of background on the project, link to my YouTube channel, obviously Twitch, you guys are here. A little bit about my goal. We also have a Discord server with about 600 people on it, roughly. And then a link to my GitHub and stuff like that. And then latest, right? So there's a lot of stuff on here. We do have auto-generated API documentation. So I have this set up whenever I check stuff into the main branch, we automatically generate documentation. So you see here we've got a bunch of stuff on all the different data structures, and then the individual files itself. So we've got, right now, only the core engine is documented. Plugins and stuff like that aren't yet, but eventually they will be. But yeah, I mean, you can click into here and have full documentation on how all this stuff works. So I'm trying to be organized about it anyway. The repo itself, everything is fully open source. So everything here is on GitHub. So everything that I'm doing on stream here always winds up being checked in, so that you guys can go ahead and grab that. And then as far as building it goes, it's really simple. All you really need is Clang and the Vulkan SDK. I have no external dependencies other than that at the moment. So literally you can just download it and use Clang to build it, and you can get it up and running. If you have VS Code with the C/C++ debugger setup, it works with that just fine. So thank you guys for the follows. I appreciate those follows. Thank you. All right. The other thing that I have, I guess I'll point this out real quick. I am in early stages on this, but I do have a wiki on here as well that I'm kind of starting to build out with a roadmap. So we have a list of features that are coming or that we need to implement. So this is kind of some of that stuff. And then these are renderer specific things. This is the UI system that we're going to be doing very soon. So we're sort of preparing to build an editor right now. And another thing that we're going to need for that editor is a UI system. So we're going to be building that very soon. And then this is all the features that we've implemented in the game engine so far, right? So hopefully all of that info helps you guys. For anybody that's interested in that, it's there. The other thing is this stream is an interactive stream. So if you guys have questions or things that you're wondering about that I'm doing, feel free to jump in. Or if you see something that is screwed up, feel free to correct me. I'm always on board with that. This is designed to be a learning resource, not only for anybody that looks at it, but I intend to also learn a lot of stuff doing this, right? So I've developed several engines in the past, commercially even, proprietary ones, but nothing really to this scale using like Vulkan or anything like that. So Morishana, introduce yourself, please. Yes, hello. So yeah, anyway, so what we're working on right now is just kind of trying to debug some things with this Gizmo and why it does that, right? Just disappears. So we'll probably do a little bit more digging into that. That's a specific thing with this particular case. But I don't want to spend too much time on it because I kind of want to get some of those other modes implemented. You ranted for the last hour. You think you don't get anything done and you're just being disingenuous because you got banned? Yeah, I mean, it's tough sometimes streaming and deving, right? It sometimes can be a little bit difficult to do both at the same time, right? I'm still learning how to do that. All right, so I think actually what I might do is we might actually hook up some object picking so that we can actually select an object in the world and then maybe use the gizmo to move it around. So I'm thinking the way that that's going to work is whenever we pick an object, which if we actually look at console.log, if we actually look at the logs here, so whenever we do a raycast hit in the scene, we return the object ID that we hit. So we can use that to query the scene and basically say, okay, give me a pointer to this object's transform. and then we can set that as our parent, and then as we move the gizmo around, we should just basically change the transform of the parent. And I'm thinking that will work. We'll see. All right. Imperator Jake, hello. Welcome. All right. Yes, it is C. Can also point out that Musashi got banned over half an hour ago and continued to lurk even through. Seems to dislike the stream. Sounds like a troll to me. Just got back into CPP myself. Yeah, I used to use CPP a lot. But I don't know. I found myself writing C like C++. And so I don't know. I was just like, why am I using C++ if it's really very close to C? And I just kind of took the plunge and just tried writing stuff in C and figured out I liked it a lot better. How do I feel about Rust? So I used Rust for probably about a week a couple of years ago, but I never really got too deep into it to form an entire opinion. So I don't feel like I'm really qualified to speak on it. I mean, I think it has some good stuff going for it, but like I said, I didn't really use it enough to consider myself qualified to speak on it. I don't even like CPP. C is the real thing. I mean, I prefer C. I much prefer C over C++. Like I said, I don't use really object-oriented programming in this project all that much. So, I typically don't really need C++. I don't use operator overloads or function overloads either. So those would be like the big things that I would use in C++ if I used it. Procedural CPP. I mean, I guess you could do procedural CPP. A lot of people do that. Or, it winds up being C-like though, right? So, I don't know. To me, it doesn't really make as much sense. Like, if I'm writing my C++ to be very C-like, why not just use C? I like managing my own memory. I don't like languages that do that for me, really. And C++, especially modern C++, tries to do that. So C was elegant and fun until you had to put typedef struct everywhere. Yeah, but I mean, technically speaking, you can macro that if it bothers you. I'll stick with C++ to keep namespaces. Yeah, namespaces are kind of cool, but I've found that I mean, the only thing that kind of sucks about not having a namespace is sometimes your names of stuff get kind of long, but it's not really that big of a deal. I don't like managing my own memory because I don't trust myself to. I mean, once you get used to doing it, though, it's not really bad. Namespaces are definitely useful, but again, I never found myself using them all that much. Because I was never a huge fan of like having to type the double colon everywhere, right? I'm going to break for ads real quick, just so that nobody misses anything. Yeah, so for those of you who can still hear me, I've got about 45 seconds left before ads are done. Okay, ads are done. So, yeah, like I don't like the colon all over the place either. And yeah, I was never a fan of like using namespace because then you pull everything in. Do you ever find yourself missing CPP features? The only thing that I miss on occasion is destructors, like scope destructors, right? Like, but it's very, very, very edge case. Like, it would be great for things like logging, right, or measuring performance, right? But yeah, again, I don't really use classes and stuff like that. Do I hand implement all my own data structures? Yeah, so I've actually done quite a lot of that. So I actually have containers in here. So I have like a dynamic array, a free list, a hash table, a ring queue, and a stack. I have a couple more that I'm going to be implementing as well, like an octree and stuff like that. But yeah, these are sort of the ones I've implemented so far. But yeah, the other reason I do this is because I can also make those use my allocators, so I can sort of modify and keep track of the way that the memory is used. And speaking of allocators, all of my all the memory in the system is actually tagged. So when I'm running, in fact, let me switch to this real quick and run this. So like every type of there's a whole bunch of categories of memory that are tagged in the system, so I can keep track of, you know, how much memory each type of thing is taking. This is like a huge list, so it's I'm probably not gonna be able to get it to fit on the screen, but I can try. There we go. Okay, so these are like all the different tags that I have in the system for the different types of memory and allocations that are happening. And I actually keep separate GPU logging for that as well. Let's see. Looks like my auto mod is being a little bit. Okay. I'm still tweaking my bot, by the way. I tweaked Nightbot recently, so he's a little bit crazy in terms of what it is auto modding. You're a filthy JavaScript dev. I mean, I'll be honest. You know, during the day, my day job, I wind up having to work with TypeScript/JavaScript. So apparently, self-deprecating humor is not allowed. If that was the case, I should ban myself because I'm all for self-deprecating humor. Rushai, thank you so much for the stretch redeem. I need to do that. That was 9 minutes ago. You only ever wrote user JavaScript scripts. What do you mean by user JavaScript scripts? Do you mean like Node? Yeah, that is yuck for me. I like standard libraries. As far as like structures go, yeah, I mean the standard libraries are decent, but I find that they're kind of they're not always necessarily the fastest, right? Sometimes just using a straight array for things is way faster. The other thing that I tend to do also is, since I'm using my own allocators, I actually have basically an arena allocator set up where I reach out and grab all that RAM at once, and then that means that I don't have to keep asking for allocations all the time, which is another reason I write my own. Tamper monkey. I can't say I'm familiar with that. For things like a hash table, yeah, I mean, in the hash table I have, the implementation of it right now isn't all that great. I need to improve it. I basically just needed something that worked at the time. There are instances where it's probably better to use something out of the box. But again, you know, the point of this series is supposed to be educational. So we kind of like to do a little bit of a deep dive into some of these things and see how they're built, type of thing. Chrome Firefox extensions. I gotcha. Okay. Yeah, I haven't done much of that outside of a few proprietary ones that I've had to do for jobs in the past, but I haven't done a whole lot of that. I know writing Chrome extensions is super annoying because stuff breaks all the time, and every time they update the browser, it like breaks tons of their stuff in their API. But yeah, anyway, so we were talking about the memory tagging. This gives me a little bit of granularity in terms of seeing how things are actually used and allocated, and it can also kind of clue me in as to if I have a memory leak somewhere. I also have this thing that runs that tells me how many allocations happened this particular frame versus the last frame that were not actually freed, right? So if there's something that's allocating all the time on every frame that isn't freed, I'm going to get notified about it here. So I've heard that. I've watched Bjarne talk about how grabbing sequential memory is significant improvement in cache hits over random access, even though that can be counterintuitive from the big O logic. Yeah, exactly. Big O is like not a perfect science, right? Cache coherency is like a huge, huge thing. Especially, I mean, PC hardware tends to deal with it pretty well, but when you start talking game consoles like PlayStation and stuff, if you start having cache misses on those, it's really significant. Pointer dereference may equal massive cache miss, and often does. Again, everything they taught me in university is wrong. Yeah, I would argue that about object-oriented programming. I mean, it's pretty much widely known now that that was kind of a mistake, but they still keep teaching it anyways. And don't get me wrong, you know, object-oriented programming kind of has its place for some things, but yeah, I've found that it's much easier to code without it. Oh, camels away. Yeah, you hate object-oriented as well. Yeah, yeah, I'm not a fan of it. I have to use it for work just because the project that we're working there is set up that way, but I hate it. I'm trying to get them to switch away from it. All right, so I think I'm gonna put a to-do in this. This just kind of disappears on occasion. Debug this. And I'm doing this because I kind of want to move on and start on the other modes. Every API in my microservice mesh has work at work has 800 plus files to map data from one. Ooh. Ouch. And it's all Java. I'm sorry to hear that. Yeah, I've had to do some Java stuff, and I'm not a fan. I feel like Microsoft kind of got it right with C#. I feel like C# is what Java should have been. But even so, it's still object-oriented and kind of gross because it's memory managed as well, garbage collected. That's why I stay in JS land. At least there I can keep my sanity. To an extent, though. You have a lot of the weird type punting stuff that happens in JavaScript, too. Yeah, C# I think is much better. I still don't use it, but I did use it for a lot of years for backend stuff. All right, let's look at testbed main, and let's kind of implement a pseudo object picking system. So one of the things that we're doing right now, you know what? Actually, I'm going to take all of this because this is just notes I put in here for the Gizmo stuff. I'm going to put this in here. Here at the top. So basically what we're going to do is, or what we're doing currently is in the game on button up, we are checking the button release, and then if the left button is actually released, we're performing a raycast at that point if there is a scene loaded. So all we're doing is we are getting all of this stuff, which we really need to fix this too, because we don't have a concept of viewports yet. That would help us at least with this bit here. So we get the view, the origin of the camera, and then the projection matrix, and we raycast into the scene. And then we query the simple scene with that raycast and say, hey, did we hit anything? And then we get our hit count, and we loop through those hits, and we sort of process it, right? And all we're doing right now is we're saying for each hit, we're drawing a debug line from the camera to where that hit was, and then we're drawing a box at the actual hit location. And that's all we're really doing with it, right? And so if we actually have multiple hits, like we kind of go through one object and hit another object, they all show up, and that's great. But we can actually use this same logic for picking, right? Because we actually have everything that we need here. We have the unique ID of the hit object, as well as things like distance and so forth. So I think we can use this to sort of start our selection code. Imperative Jake, thank you for the follow. Appreciate it. So I want to move our stack to Go because Go is so simple, but it won't happen for years. I have not used Go, so I don't know much about it. Skip a step and move to Python right away. Oh, Python. Python. Okay. If Go actually had manual alloc free, I wonder, would it be good for game dev? I have no idea. That's an interesting take, though. So U32, Vector 3, those are your types. I haven't written in C, but those are my types. Yeah, so if we go to definition here, so like wait a minute, you were asking about the U32, right? Yeah, U32. So these are just type defs, right? So these are just ones that I put in place. And then things like the vector, obviously, are my types as well. So those are basically just fancy unions. Don't get me wrong, I love some Python, but mostly only for data analysis. I feel like that's what it's most widely used for. Or the occasional, like IT tool or something. To just like move files around or quickly gather data, I guess, from files, right? Kind of the same thing. All right, so I'm going to go to the game state. And this is kind of where we're putting all of our temporary crap, right, in the game state. Incidentally, I should probably mention for those of you who are new to this project, so the way that this project is architected is the engine is actually a library. It's a shared library. And that is meant to be consumed by an application. So basically what we're going to do is we have this testbed application right now. So every time I add a feature, I just kind of manually code stuff into that testbed application. That's what this guy here is. And then I have this testbed lib, which is basically some logic that the testbed application uses. So testbed itself is an executable, but testbed lib is a shared library. And the reason I did that is because we can actually hot reload the testbed library. So instead of implementing a game scripting language, I've implemented hot reloading so that we can basically make changes to the testbed code, compile it, and then as soon as we have a new DLL on Windows or an SO file here, we can hot reload that and reload in all of the code and get the updated code, right? And so I have that. I have some unit tests here as well. I have some command line tools that I've written for converting meshes and things like that. That will be expanded as well. And then the Vulkan renderer is actually designed as a plugin. So I kind of came up with this idea of one of the things that I want to do with this engine is the engine's going to have a lot of basic functionality incorporated into it. But things like the renderer and eventually like the sound and the physics engine and all that is going to be, those are all going to be plugin based. So the core engine will not provide that functionality. It'll be a plugin that we add. And the reason I'm doing that is because like we can use a Vulkan renderer as one plugin. We can have an OpenGL renderer, a DirectX renderer, a Metal renderer. Those are all things we're going to be implementing with this. And so this engine has been designed to work with all of those different backends and just use a different plugin. And so the physics plugin will be the same way. We'll probably wind up making our super simple like physics engine. And then we'll probably have like an NVIDIA PhysX plugin or a Bullet plugin, stuff like that, right? So there's that. Let me see. Simple bots, yes. Simple bots are also used. Also, you tend to use Python. Best HTTP server for local. I don't know. I just use for an HTTP server. I usually use live server, which I think is just it's written in Node, so that's the one I usually use. Just because it works on all OSs, all platforms. All right, so I think the way that I'm going to handle selected objects for now, since we're technically going to have two pieces of information that I can think of off the top of my head that we're going to need to keep. So I'm going to type def struct, and we're going to call this selected object. And it's going to have a U32 unique ID. And it's going to have a... Do I have transform here? I don't think I do. It's going to have a pointer to a transform. I'll call this xform of the selected object. So I think I'm going to have to forward declare that. Right. And then all we'll do is I'll just cram this here at the end. Selected object selection. And then and initialize when we set up the state, which is done here. I will say state selection. And I'll set the unique ID to invalid ID U32, which is actually just the invalid ID, and the state selection xform to be null, right? And basically we can just look at those things to determine whether or not we have a selection. I think we're going to have to modify simple scene to actually select by unique ID because we don't have that in there right now. So a scene is actually something else that is determined outside the engine. So the engine doesn't have any concept of a scene. So we have this concept of what I call a simple scene, which is exactly what it sounds like. It's not designed to be fast. It's not designed to be super robust or anything like that. It's literally designed to be as simple as possible to just give us a scene to hold a bunch of objects, right? And the reason I did it this way is because each application sort of has its own requirements as to what it needs. So we might be writing a game that only has these requirements, right? Super simple requirements for a scene. Or we might be writing a game that requires an entire ECS and an ECS scene, or an entity component system, right? And so entity component system is not something that's going to be in the core engine. That's going to be a plugin, and then a entity component system scene would be part of that plugin. So that's another example of something we're going to be implementing, but it's not going to be part of the core engine. It's going to be a plugin. And right now, all this stuff is sort of in the same repo. Eventually, it'll wind up being split out, and I'll set up some sort of system where we can pull in only the things we need. So, where was I? So we have our simple scene lifetime objects here. Here is where we actually query for all the different types of objects. So these are the adds, these are removes, these are the queries right here to get objects of a specific type. We are going to be adding something that's a little bit more generic than what we've been dealing with so far, which is actually going to be, before I add that, let's see, do we have transform here? We do not. All right, so struct transform. All right, so what we're going to do here is we are going to add a new feature, or a new function rather, to provide a scene and a unique ID and return a pointer to a transform. I'm thinking that's the best way to do it. Yeah, that's how I'm going to do it for right now. Okay, I was considering maybe using a Boolean interface instead, but for now it's just going to be struct transform pointer, and then we'll say simple scene transform get by ID, and we'll take the simple scene and the U32 unique, if I could type, ID, right? And if it doesn't find it, we'll just return a null pointer. So we'll go to simple scene C, and this is going to be super gross the way that we're going to implement this, but it is a simple scene. Like I said, it is not designed to be robust. So this is what we're doing for right now. Eventually, once we have some other data structures in mind or in place to actually make this a little bit more robust, we might do that. But for right now, this is what we're doing. So we're going to do a sanity check first. So if we don't have a scene, obviously there's nothing to query, so we can return 0. Otherwise, we are basically going to loop through all of these different things. Lights don't have unique IDs, so we're not going to loop through those. I don't think the skybox does either. I'm trying to remember. I know meshes do, but I don't think skyboxes do, and there's no real reason we should need to select that anyways, right? We're just really worried about stuff that's sort of in the world. So I'll start with meshes. So we'll say U32 mesh count, and we'll go with darray length scene meshes, and then we'll just loop through each one of these guys, and we'll say U32 I equals 0, I is less than mesh count plus I, and then if scene meshes sub I unique ID equals unique ID, then we will return scene meshes sub I transform, and we'll actually need the address of that, right? And then we'll say down here return 0 if we don't find anything. So we'll do that for meshes. I think the terrain also has unique ID, I want to say. Scene terrains. Why am I not getting... Oh. Because I'm a bananist, that's why. Yeah, so terrains do have that as well, so... you know what? I'm just gonna... copy pasta this. So this is gonna be... terrain counts. Terrains. Terrain counts. Terrains. And terrains transform. Ooh, does terrain not have a transform? Or did I call it X form, like I've done some other places? Yeah, I did. I really need to, I need to fix that. Because we have transform, but it's also called transform, which is kind of bad. I should just call it X form everywhere. I don't want to do it now, because that's going to be kind of a widespread change. But, yeah, we'll come back to that. Just make a note of it. Let's see. I don't miss the decoupled header files from implementation. Always felt weird. I don't know, I'm just used to it. Doesn't really bother me anymore. And it allows you to do some kind of cool stuff. Maybe I've written JavaScript, TypeScript for too long. Yeah. Is darray a heap allocated array? Yes, it is. That's similar to how a vector works, like an STD vector. It's just an expanding array, is all it is. darray is dynamic array. What are naming conventions anyway? So our naming convention is basically what we're what we're trying to shoot for, and it's changed since I started the project, because, and that's why there's some inconsistencies. Stuff that's really old is kind of named funky. Like for functions, I try to do the thing that we're acting against, and then the action at the end of that, right? Yeah, I guess that's more or less what I'm doing. But it's not consistent everywhere, because I had some different things in mind when I started the project. Like I said, this has been around for about 2 years. So I probably would be a lot farther along, honestly, if I weren't streaming and or YouTubing the entire thing, because the only time I actually dev on this is when I'm here, right? We have ads, so I'm going to pause. Got about 45 seconds left on ads. About 10 seconds. Cool. All right. So I don't know if you guys were here during the last ad break or not, but yeah, I try to pause the stream when ads come up so that way that anybody that's not subbed or whatnot or doesn't have the what is it, Twitch Prime, don't miss content because of the ads. Although I do post all of this stuff to YouTube, so it's always available there as well. Okay. So I think for now, let's see, we don't want to select debug geometries. Debug geometries are those lines and boxes that we sort of create for debugging purposes. Our mesh, or our grid rather, also counts as that. So I think meshes and terrains are probably all we need to do for that for right now. So if we do find one of those things that matches, we'll go ahead and return a pointer to it. Otherwise, a pointer to its transform rather. Otherwise, we will return 0. So I think now we can go back to testbed main and let's do button up, which actually this should just be game on button because we actually handle press events here, even though we're not actually doing anything with it right now. We actually do handle that, so I'm going to rename this to just game on button. So when we click, I think we're going to leave this debug logic in here for right now. But what we're going to do is on the first object that we actually hit of the list, we're going to go ahead and select that object. So I guess I can go ahead and let's do it down here. Now, ordinarily, once we put this into the editor, we're going to port all of this logic to the editor. Obviously, it'll be way neater than this, right? We're just kind of jamming things under our testbed right now just to kind of see what works, right? That's the whole point of the testbed application, right? So the testbed doesn't necessarily have to be neat. It's a testbed. So we'll say if I equals 0, then we'll say state selection unique ID equals hit unique ID and state selection x form, which is a pointer, will be simple scene transform get by ID. So we'll pass the state main scene, which we're actually going to need the address of that because it's a pointer. And we'll pass the hit unique ID. And then at this point, we'll go ahead and check to make sure that we actually got a transform back. So we'll say if, yeah, we'll do a positive check. Selection x form. Then for right now, let's just blend it out to the console. So we'll say k info selected object ID hit.unique ID. Right? And maybe for right now, we'll move the gizmo to its position. Because now that I think about it, if we just parent the gizmo to that, there's going to be some scaling issues, I think. Especially since the objects that we have in the scene are really scaled small right now. Is a dereference dot field, right? Yeah. Yep, you're correct about that. Yeah, so basically, this is arguably a strange thing about C and C++ is that it has this different point syntax for pointers. I mean, it kind of makes sense, but you know, if you're dealing with something that's a pointer, you have to use this arrow syntax versus the dot if you're dealing with something that isn't a pointer. Okay, so I guess what I'll do is we'll say state Gizmo xform, and I think for right now, you know what? Screw it. Let's apply the parent so that you guys can see what I'm talking about. So we'll do transform parent. Whoops. Parent set. So this is the transform that we're going to be setting as the child, and then we're going to say the state selection xform, and we need the address of that, is going to be the parent, right? Oh, that's already a pointer. I don't need the address of that, right? See, that stuff screws me up too. Pointers versus non-pointers. Sometimes you have to pass the address, sometimes you don't. Still screws me up every once in a while. All right. So for now, we're just going to set the transform and see if that works. I'm going to write all build. And we will go to our debugger here. And I'm just going to switch to our move mode to make it a little bit easier to see, and I'll load up our scene. And all I'm going to do is I'm just going to click this car over here and see what we get. And it looks like it might have worked, but I'm guessing. I'm going to guess that the transform is so small we probably can't see it, because this is actually a really huge object. And where the heck is it? I'm not seeing it. Is it like buried in a seat or something? Did it just disappear is the question. It's all the way over there. What is it doing over there? Help me understand that. Oh, I bet I know what's happening. Okay. So it doesn't actually have anything to do with this. It has a lot to do with what we're doing in the editor view. And I was saying before that I wasn't sure that this logic was right, and now I'm pretty sure it's not right. So what we were doing is we were setting up this sort of scale factor to try and get the gizmo to be a fixed size on the screen. And I'm thinking we're just doing this completely wrong. And so what I think is happening is this is actually interfering with what we're trying to do. Is it parent transform? So I think our parenting works right. I mean, that's been in place for forever, and I've pretty thoroughly tested it, so I'm pretty sure that that's going to be correct. But what I'm going to do is I'm going to hard code this to 1.0 for right now. Which probably means that... let's see. Actually, instead of hard coding that, I'm going to hard code this, because that's actually what's being used. It's probably going to bleat at me about unused variables now. Yep. FOV, distance, and fixed size. Okay. Now it's camera position and gizmo position. Sure. Kill those two. Okay. So I'm wondering, so basically now we can actually get like right up on the gizmo, right? And if we load up our scene, we'll really be able to see this, right? So we can get like right up on it. So now I'm wondering if it'll actually kind of do the thing that it's supposed to do. So I'll click on this guy, and yeah, it did. So it totally was that logic that I had in place before. So I'm gonna have to figure that out, because the issue is when we back away from our object, right? That gizmo gets smaller and smaller and smaller and smaller, right? And like, there's no way that you're gonna be able to like reliably interact with that, right? So something about my calculation there with the scaling and stuff just made that completely wrong. And I have a feeling it has to do something with the fact that I'm applying it this way, I'm thinking. So I'll have to like look into that. It's probably going to be something really annoying that I'm going to have to sort of research a little bit further off camera and then come back with a solution. But at least for now, we actually have the ability to load up the scene and select an object. So just to prove this a little bit further, I'll go back up a little bit, and so we'll select this object, and then we'll select this, and it should be somewhere. Now this one is actually probably going to be, this one's probably going to be comically small. We might not even be able to render it on the screen. I think that's probably, yep, it is. There it is right there. Where was it? It's like if you look right here, you can see it. And the reason for that is, if we take a look at our scene file, our Sponza mesh is really, really small. This is our scale, right? So the scale, obviously, since it's since the gizmo is parented, or I should say a child to the mesh that's selected, it's obviously not right. So I think probably what I'm gonna have to do is, instead of treating it like a parent, what's my font? Like my editor font? Is that what you mean? Thank you for the follow. I appreciate that. I'm thinking what I am going to need to do here is probably... Oops, that's not the one I wanted. I'm thinking what I'm going to have to do is, instead of parenting it directly like this, I think I'm going to have to create a new transform that only includes the position and the rotation. And that's going to have to be based off of the world transform of the object. And then set the gizmo to use that. And then somehow synchronize the two. That way we won't be affected by scale. Because otherwise I'd have to like walk up the transform tree and try to negate the scale, which is, it's just not doable, right? If you have dozens of layers deep, like, you don't want to be doing that all the time. If you're asking about my font, by the way, that I'm using in Vim, it's the Meslo Nerd font. Let me think. How do I want to do this? Because, so I guess the gizmo itself should probably have a reference to the transform, which would be different than parenting it, right? So we keep a reference to that. Every time we update, we'll have to update the gizmo every frame, I guess. And then extract the scale and rotation out of the parent's transform and use that. Do I have... I know I can... I should just be able to... Yeah, I should be able to do that fairly easily, because we have gets for all of those. Alright, so let me go to here, and I'm going to add a second transform. But this is going to be a pointer, and we're going to call this selected object transform, or just selected X form, I guess is good enough. A pointer to the currently selected objects, for lack of a better term, transform. Null if nothing is selected. So in editor gizmo create, we'll also have to initialize this out gizmo. I suppose I don't really have to do this, because technically we could just zero the memory, but I prefer to be explicit, right? So the selected X form is null. So technically speaking, if we don't have a selection, we shouldn't be showing the gizmo anyways. So eventually we're just not going to render this thing if we don't have anything selected. But for right now, while we're still kind of building it, I don't really want to have that requirement yet. Writing a neovim and compiling and command prompt actually feels OP. Yeah, this is actually just the terminal, right? So I'm using tmux here to switch between, right? So I'm using ZSH as my instead of bash, but only cd d to get to the D. Yes. Better to use a split and toggle into command and vim. Yeah, I've done that before. I mean, like, I could do... I could do that, right? But that's... I don't know, like, I found it kind of annoying. Like, because then you gotta find it in here. I don't know. It just feels like the part that's weird to me is, like, when you're in normal mode, you actually have to go into insert mode in order to actually type anything in. And then, you know, so that works fine. Oh, I didn't shut this off. I was still running. But then, you know, to get out of that, you actually have to hit escape and then, like, wait a second. So let me do that again. So, like, I'm in insert mode, which takes me into terminal mode, and then it's like there's a second of delay before I can actually swap over to a different... I don't know, it's just weird. For me, it's quicker for me to hit Control BN, but I don't know. I mean, I could do it. I have done it this way on stream. Doesn't really make that much of a difference, honestly. You know, and I can always do this too, right? I could just click it, I guess, but whatever. To each their own. I've done it this way in stream before. It works. So does this. Okay. So I don't think we actually have, we do have an update. I just haven't actually used it for anything yet. So now we're actually going to use this. So if Gizmo selected X form, so if we have a selected X form, then what we're going to do is, and this is not going to be optimized, but then again, I don't think the stuff that we're going to be doing is that heavy. We could probably cache it and reduce some of this math that we're going to do, but for right now, actually, I think I might actually just be able to do transform position set. We'll pass the address of the Gizmo X form, and for position, we'll get the Gizmo selected X form position. So we can actually do that, and then rotation set, and do the same thing with rotation. Actually, I think that's all we have to do. So all these do, for reference, oh, that's not going to give me the actual right one. All right. So we go to position set, for example. All this does is just copies over the position and then sets an internal dirty flag to true. So we don't recalculate the matrix right then and there. What we do is we wait until we actually go to get the world transform of that matrix and then say, hey, go ahead and get the local transform, and if that is dirty, then we recalculate it, right? And then we do the thing. Control backslash plus control N plus control W, control W. I can't even think off the top of my head what that does. Too many key bindings, yeah. No need to use a split. I wonder if there's a C file watcher that could recompile on save. There probably is. I don't know if I'd want to do that though. Because I hit, yeah, I do this all the time, right? I don't know if I'd want it to try recompiling every time because I do it like every 10 seconds. Nested ifs. That toggles you out of terminal mode and change. Oh, okay. Yeah. You know what? I actually have a shortcut to actually do that for me as well. I actually have it in my Vim config to actually just allow me to hit escape to actually do all that crap for me, so I don't have to do it manually. I forgot about that actually. Yeah, I think it's the same thing on just straight up Linux itself. Like, I remember now having to look that up. I don't remember exactly what it was, but so I think it was what was it? Keybinds, I think. I think I had it under here somewhere. Oh yeah, here it is right here. That line. So I just mapped escape to actually do control backslash control N for me. Because that got really annoying. Yeah, you can't use Vim without configuring for a while. Yeah, as you can see here, I've got A lot of config. Yeah, I spent quite a lot of time configuring it. It's kind of ridiculous, actually. Anyway. So I think actually this is the only thing that we have to do here, and then that should automatically update it. So the second that we set a selected X form on the Gizmo, this should automatically kick in and work. But I don't think we're actually calling editor Gizmo update, so we need to actually do that. So in the application updates, we do the simple scene update. This is probably right where we want to do it, actually. So, editor, Gizmo, oops, update. And this is going to be state, Gizmo. And I think we do the address of that. All right, so we have that. And then instead of setting the parent, we are going to do state Gizmo selected X form equals state selection X form. And then if we have no hit, we actually need to deselect. So I'm going to go ahead here and just say if state.selection X form. Actually, I could probably just set these things. I don't even think I need to check this. I think I could just get away with setting it. So state selection X form is null. State selection unique ID equals invalid ID. I think that's actually all we need to do to get selections working. Now, obviously, we're eventually going to want like a much more robust system than this, but for our testbed purposes, this should be fine. So I guess, let's go here and build. Right, and then run here. And load up our scene. And we should be able to click that. And it looks like, yeah, the scale looks better this time. So I should be able to then click the sponza. And we can see our sponza now has the transform in its center. And then I think if I deselect, it's probably not going to affect that at all. Yeah, no, it's not going to change it. I mean, it unset it, but it's not going to change it. I'm going to pause the stream for ads. Another 10 seconds. Cool. All right, so we're done with that. Uh, Imperative Jake, I use Prime's config because I'm lazy. Yeah, the problem I found with using other people's configs is I don't understand them, and when stuff breaks, it's terrible. I'm not going to say I fully 100% understand everything I have here, but I definitely understand it enough because I pieced it together bit by bit. So anyway, I think this is probably where we're going to wrap the stream for tonight, simply because I have to work in the morning. But thank you guys all so much for joining me on here. I really appreciate it. I appreciate the raid and all of you guys, who stayed. And I would ask if you find this project interesting, please, give me a follow, because I would really appreciate that. I'm trying to grow the channel, it's a fairly new channel, so it's small at the moment, but it's a lot of fun. So I'm having a lot of fun doing this, and it seems like you guys kind of like what I'm doing. So if you do like what I'm doing, I would ask that you follow, and I appreciate all of you who have followed. And like I said, all of these videos will be archived onto the YouTube channel as well, and available there. I usually have them a couple weeks behind, just because of the way that things kind of have worked out. It takes me a bit to sort of edit them and get them reposted and upload them and all that. So, but anyway, let me look for a channel to raid. I think I'm gonna go with my faithful channel that I raid a lot here, which is gonna be Ferret Software. So for those of you who don't know who they are, Ferret Software is actually a ferret rescue that is run by a fellow game developer, Pirate Software. And basically what they do is they take ferrets that have been used for like medical testing and stuff like that, and the company that the main supplier to the government and all that supplies all these ferrets, they usually use them for a year to test stuff, and then they basically put them down or discard them, as they say. And so what Thor, the game developer, Pirate Software, does is he actually takes those in and he gives them a good home, and he uses all the ad revenue from the stream to take care of their medical expenses, pays for their food, things like that. They're very expensive to take care of properly. And I really like what he's doing with it. And so I'm going to go ahead and support that channel with a raid, because I really like what he's doing with it, and I think it's a really good cause. And yeah, so again, thank you guys so much for following me along and joining me here and interacting. It's been a lot of fun. And I will see you guys. The next stream is going to be next Wednesday night at 9 p.m. EST. So I will see you guys then.